Primary clustering versus secondary clustering. Let us first understand what is clustering and then we'll look into primary clustering and secondary clustering. Clustering refers to the formation of groups of occupied slots in a hash table. What is the problem with formation of groups of occupied slots? The problem is such clusters always degrades the performance of your hashing operations. Let us understand this from a hash table. Let us say this is your hash table. If you have a table like this and there are a lot of blocks in this hash table, what is clustering here? If there are some blocks, let us say these blocks, which are occupied and forms a cluster. This is a group of blocks and they are occupied and we call it a cluster. If such clusters are formed, why is it degrading your operations performance? The reason is if you have any key, what will you generally do? You will use a hash function and you will generate a hash value. Once you have the hash value, you will map it to this table that you're having. What happens if you so happened to map to any of these blocks? You will not be able to put this value into that block because it is already occupied. Because it is occupied, you have to start a probing sequence which will look for the next available slot. So you have to go through this probing sequence, and because of this probing sequence, your performance of hashing operation will degrade. This is the reason why whenever you have a cluster in your hash table, the performance of your hashing operation will go down. Let us understand specific to primary clustering and secondary clustering. What exactly is the problem and in what situations is it affected? First is primary clustering. What is primary clustering? Primary clustering occurs whenever a group of consecutive slots in the hash table becomes filled. This is exactly what we had shown here. That is, these blocks are consecutive blocks. Whenever consecutive blocks form a cluster, it is called as primary clustering. And one thing to note here is primary clustering always happens when you use linear probing. In the last lecture, we learned about linear probing, which is an open addressing technique. Whenever you use this particular technique in order to probe, primary cluster is always bound to happen. Why is it? Because as more and more keys are inserted, collisions will tend to grow. And what happens? This cluster will become larger and larger. And when the cluster becomes larger, in future, insertion and searches become even more difficult. Let us understand this. What happens? Presently, let us say this cluster is of size 4. What happens if I have some key that is coming in? If that key maps to any of these blocks, what will happen? It will search for the next available block in order to insert this key. And what will it find? It will find the block right after the end of this cluster. That is, we are considering linear probing. What happens in linear probing? If you are searching for one particular block and it is occupied, what will you do? You will search for the next block. If that is also occupied, you will search for next one, and so on. This is linear probing. Because of linear probing, whenever a cluster is formed, a primary cluster is formed, what happens? The next element which is mapped to any of these clustered blocks will be allotted to the block right after the cluster. What happens then? This block also gets added to the cluster. So the cluster is larger now. It is having 5 blocks. And what is the repercussion of this? Because you are having 5 blocks, next time instead of 4, if your mapping of the key is to any of these 5 blocks, it is going to have the effect of same cluster. And what happens next? It will get mapped to the next block. So your cluster size is even larger now. So as you keep inserting more and more elements, and as these elements keep hitting the same cluster, what happens? One, the cluster size increases, that is even faster and faster, it keeps increasing, and more keys start getting affected by this cluster. So this is the problem with primary cluster. So, what can you understand from this? You can understand that this is applicable, that is, primary cluster is applicable only when you have consecutive blocks which are part of the cluster. Okay. So, and that it always occurs in linear probing. So, the next thing is, what is secondary cluster? What is secondary cluster? You already understood primary cluster. What is secondary cluster and how is it different from primary cluster? In case of primary cluster, the main point was that the cluster should have consecutive blocks. Then only it is called as primary cluster. But in case of secondary cluster, it need not be it need not be consecutive blocks. Instead, how does it occur? It occurs whenever keys hash to the same index and follow the same probing sequence. So there are two conditions here. One is your probing sequence, whichever it be. If it is deterministic probing sequence, then it will be affected by secondary cluster. This is the first condition, that you should have a deterministic probing sequence. Second condition is that all the values that are affected by this particular cluster will be mapped to the same index. In case of primary cluster, if you map to any of these indices which were part of the cluster, it would have been affecting this primary clustering. But in case of secondary cluster, there will be one particular block which is affected by the secondary cluster, which is the origin of this cluster. Whenever you have another key which is mapping to the same block, then only secondary cluster applies. But primary cluster, it applies if you map to any of these blocks which are part of the cluster. This is the main difference. And why is it so? Why is it that in case of secondary cluster, it affects only when you are mapping to the first block which is part of this cluster, that is the origin block? Why is it? Let us understand. We'll again draw the hash table here. In this hash table, what is the scenario of secondary cluster? Let us say I mapped some key to this table and I found that this is the block to which I should map the key. And it is already occupied. I'll number this so as to understand the probing sequence. This is the first block that I tried to insert, but this block is occupied. What will I do? I will use my probing sequence. So keep in mind, this time I'm not using linear probing. Linear probing also has secondary cluster, but in order to understand the difference between primary and secondary, let us assume this is some random probing sequence, okay? But it is a probing sequence which is deterministic. That is, every time you map to the same block, the sequence followed will be same. That is what I meant by deterministic. Let us say the second block that the probing sequence found is this, okay? And this also, let us say, appears to be occupied. And third one in the probing sequence is this. And fourth one is, let us say, this. So these are the four blocks which are part of the present probing sequence. What happens if you have one more key which is hashing to the same first block? In this case, again it will probe the same second block, then it will probe the same third block, same fourth block. So it is following the same path again and again. The same pattern is followed by the next key as well. And this is called as secondary clustering. That is, when you map all these keys, whichever key get mapped to this same index follows the same path and has to follow the same probing sequence. When will this happen? One, when you have a probing sequence which is deterministic, that is, every time it follows the same path. And secondly, it should affect the same starting index. Then only it is applicable. Why is it not applicable if you have a different starting index? Let us say instead of first block, I am mapping my next key to this block. What happens then? This is not occupied, but the second block may be this one for this particular sequence, because this is a sequence starting from a different block, because of which next block will be different. This is why secondary clustering affects much lesser blocks compared to that of primary clustering. So you can say primary clustering is very severe problem, but secondary clustering is not that severe, because in case of primary clustering, once you form a cluster, if you map to any of the blocks in that cluster, it is going to enlarge the cluster and it is going to bubble up the problem. But in case of secondary clustering, the issue occurs only when you hit the same starting block, right? And next thing is, we already said linear probing, it is prone to primary clustering. It is prone to secondary clustering as well. But in case of secondary clustering, there are even more probing sequences which get affected. For example, if you have quadratic probing, what happens in quadratic probing? Instead of linear, you are not going to next block like linear probing. That is not what you are going to do in quadratic. Instead, you will jump a lot of slots like this. But still, the sequence remains same whenever you have the same starting index. Because of this, quadratic probing is prone to secondary clustering. What about your linear probing? Okay, let us understand this separately for each probing once. In case of linear probing, what happens? Let us see primary clustering, secondary clustering. In case of linear probing, is primary clustering applicable? Yes, because you are going to next block in the probing sequence, because of which it will form consecutive set of blocks which are clustered, which are occupied, and linear probing gets affected by primary clustering. What about secondary clustering? It also gets affected because in case of linear probing, whenever you have the same starting index, the probing sequence is same, because of which it is affected by both primary clustering as well as secondary clustering. What about quadratic probing? In case of quadratic probing, see, if probing sequence you are not very clear about, visit the previous lecture. The just previous lecture we discussed about probing sequences. So let's go forward. In case of quadratic probing, what about primary clustering? This time you are going to jump certain steps, because of which you are not going to form continuous blocks of occupied memory. And that would say primary clustering is not applicable in quadratic probing. What about secondary clustering? Yes, it is applicable because in this case your sequence is deterministic. Whenever you have the same starting index, you are going to follow the same route, same path, same probing sequence, because of which secondary clustering is applicable. What about double hashing? In double hashing, you are having two hash functions, but again, both these hash functions will ultimately lead you to the same probing sequence whenever you have first index as same. The key value as same. That is, whenever you have a key value, the same key value if you give 2-3 times, or you have different keys which map to the same first index, if it so happens that the first index is same, the remaining indices in the pattern would also be same for all of them. Because of which, in case of double hashing as well, secondary clustering is applicable. Primary clustering is not applicable. So keep in mind, linear probing is affected by both primary and secondary clustering, while quadratic probing and double hashing, these are only affected by secondary clustering.